Hello and welcome to session 219 in the AISafety.com reading group. Tonight we will be discussing the article Misconceptions about Continuous Takeoff by Matthew Barnett. Matthew Barnett studies computer science at the University of California, Berkeley, and this is a post on Alignment Forum and Livestrong, which is around 2.5 years old. So before we dive into the article, I would like to give a bit of my personal view on continuity. And of course, this is a mathematical concept that was formalized by Karl Weierstrass. And the way mathematicians look at whether a function is continuous, there are several definitions, but one of them is that for all points in the domain, there must be if someone challenges you with an epsilon and says, is this continuous within epsilon, then you must be able to provide a delta so that within all points that are only delta away from this point where you are wondering if the function is continuous, then the value of the function must at most be epsilon from what it is in the middle. So let's say here is an example where we have a function here, and the challenger asks us, is this continuous in the point x equal 2 for an epsilon equal 1/2? And in this case, we need to come up with a, so if epsilon is 1/2, then we can come up with a delta that is also 1/2, and within this area here, then the function is wholly contained within this blue area here. So that's a rigorous definition of continuity, of a continuous function. So in our case, of course, what we're really talking about is the trajectory of AI capability. So that means that the x-axis is usually taken to be time, and the y-axis is capability in some sort. And there are many ways to define capability. Normally, when I need to define it, I use either the best of Bostrom's 6 cognitive superpowers or just intelligence amplification, the ability to recursively self-improve. I believe this is probably really tightly correlated with general intelligence, so it probably doesn't matter so much, but for many practical purposes, this is far more interesting. Also, we'll notice that when you announce a project, that's only a single point in time. So if you want to have something that is defined for all points, you can say that then it's the capability of the most capable system at this point in time. And in this case, of course, it is continuous precisely in the cases where a new project is introduced. Then if the state of the art is here, and then there's a new project with this capability, then there's a discontinuity between these 2 points. So a better definition of continuity as regards to AI capability growth would be something where we have an epsilon continuity, which is a lower bound, an upper bound on how much the different systems are improving on each other. So that would mean that it would be possible for someone to make the following statement: I am 80% sure that we will never see a 25% discontinuity, meaning that we will never see one that is have 125% the performance of the previous system. And if people made this kind of statement, we could investigate rigorously, has there ever been a 25% discontinuity in the past? How large have discontinuities we've seen, and how bad is it to be 25% more powerful than the previous? What can you do with that in practice? And if you're only 80% sure, then the 20% where you see more than 25, is that like 30% or is that like 3,000%? I think these are the kind of questions that come up naturally if you use this epsilon definition here that I suggest. So to go to the actual article by Matthew Barnett, so for the question of if AI will experience a discontinuity, he says the terminology is confusing and diverse. And He provides his own definition, saying that it will follow a trajectory that is roughly in line with the expectations, or the negation that there is not a point where a single project leaps very much ahead. So here there is much more competent than other projects. So the standard way that normally we graph AI capability improvements is this figure from Nick Bostrom's book Superintelligence Chapter 4, where we have the kinetics of an intelligence explosion, where we're talking about the time from we get AGI until we have something like a superintelligence, and whether this function from here to here will be continuous or discontinuous. It should be noted that Nick Bostrom in the book Superintelligence does talk about discontinuity a bit in a footnote when he's talking about this, but Bostrom focused very much on the duration from this time to this time. So there are a number of differences between how Matthew Barnett uses and how I, or perhaps Nick Bostrom, conceptualizes this. First, whether the data points are projects or models. Like you could imagine that if you have something like alpha go that turns into alpha star and mu alpha 0 and mu 0, do they count as one project or do they count as several projects? And that has a very large influence on how discontinuous it is, because surely if you count them all together as one, then it's a huge discontinuity in the ability to play Go. And it seems here that the word Matthew Barnett is using for how much more competent it is, like much more, it's quite unclear what that is. So I would have preferred an epsilon, even like 60% or something like that. Also, Matthew Barnett is not really talking about capability as much as competence plus power, which is a bit strange. I would imagine that if you have two AI systems that are the same level of intelligence, but one of them is controlling the stock market and the other one is not, or one of them is controlling nuclear weapons or something, that's not really what we're talking about when we're talking about here, even though there are obvious AI safety components to giving nuclear weapons to an AI. Also, one thing from Matthew's article that isn't quite clear is that I believe it sounds like he's disregarding this precise point, the point where the first AGI, the first project that achieves general intelligence at a human baseline level. And that's, of course, a discontinuity. Well, every new project is a discontinuity, but that's one of the ones that we are most interested in particular if it will do a fast takeoff. So for the actual misconception, the first, continuous doesn't necessarily mean slow. Matthew Barnett prefers to talk about continuous rather than slow or fast, because he believes this is the thing that is more strategically relevant. To me, I think I must have a very different conception of strategy, right? The time on the clock seems to matter very much for what preparations you can do, what actions you can take. I mean, surely in the reductio case where we have like a takeoff that is like 5 minutes, then whether it's continuous or discontinuous doesn't matter very much. Matthew talks about that the capabilities that are gained are the ones that are really interesting, somewhat in maybe a bit more binary way that I would describe it. And the example that he uses is generative adversarial networks. The way that given a facial recognition neural network, you can actually ask it, how does a face look like? And then you get, in 2014, you got something like this. And in 2018, you get something that looks very much like a photo of a person. And this here, from over the course of 4 years, that's fast development relative to humans. Bostrom would call this a medium takeoff in the ability to create images in this way. Matthew Barnett makes the following statement. It would be unusual if someone right now in late 2019 produces videos in high definition using generative adversarial networks. So this is for still images. For videos, he believes that we are currently have like videos like this, and it would be strange if someone had far better, discontinuously far better technology than what was available, than what he believes is available. So I actually looked this up to see when was the first high definition deepfakes created, and I managed to find a report referenced in IEEE saying that there were highly realistic seamless videos, so not necessarily HD, but in fact before this prediction was made. So it references, unfortunately, a dead link, so I can't say precisely, but if you count this, that he would be surprised if someone did this and then in fact this had already happened. So that counts as a, I don't know if you can say a prediction if you say something that is already false, but that's large power differentials can still happen in a continuous takeoff. That's another of these misconceptions that he is trying to clear up, and that's of course true in the obvious way that you can have large power differentials even without AI at all. So of course, whether AI is continuous or discontinuous, you still have differentials in power. The example he uses is in the ability to produce rifles. I'm not really very fond of that example. I think in most of the wars during the Industrial Revolution, the way that the industrialized nations took powers didn't have very much to do with rifles. They had more to do with the perhaps nebulous concept, industry writ large. I think so. So the point stands, but I don't like the specific way it's phrased. And in particular, we can see that a single nation or corporation can pull ahead. That is something that can happen and has happened. And here, when you're talking about one nation or one corporation, then it's the obvious question here becomes, if you have two projects that are created by the same nation or the same corporation or the same small team or whatever, when are they distant enough that there is a strategic effect from the fact that there is an intermediate, right? You can imagine that if, for instance, with AlphaGo, AlphaZero, if all these projects belong to the same stakeholder, then there might not be so much of a strategic effect on this. You could argue, for instance, that once it's made public, then a number of people will be able to react. So whether it's public is important, whether the safety implications can be learned is really, really important, whether the stakeholders are the same. Maybe if there are several AIs that are smart enough to cooperate, which they probably will be after LGI, then whether there's something preventing that or if they're capable seems like it's really important. Then there's a somewhat odd misconception whether continuous takeoff requires that you have emulations of humans. That was perhaps something that you could infer from the AI FOOM debate with Robin Hanson, and he back then, people who disagreed with fast takeoff probably agreed with Hanson, and that might be a reason to conflate these two things. I'm actually not entirely sure. I believe this is what Robin Hanson states. Now, trying to summarize Robin Hanson's ideas and predictions is a dangerous business, but I'll try. In the age of M, he sees emulations that are that once you have a human, then it's really easy to get something like an order of magnitude improvement by just pruning away things, but that leaves a core that is very hard to substantially improve. And so there is something that is roughly 10 times as fast and as smart as a human, but not more than that, and it doesn't get smarter in any really continuous way. So instead, he's discussing how would a society based on these ends actually look. I think the fact that it goes up and then it kind of stops, that sounds to me like a discontinuity, like also because after the age of m it goes up again. So this is both slow and discontinuous, I think, but I'm not quite sure Robin Hanson would agree with how I frame his views. Then there's the question about recursive self-improvement, whether that is compatible with continuous takeoff. Matthew Barnett believes it is. I guess probably also it is. But here we have something very on the inside view, a very clear example of something that could cause a discontinuity, because recursive self-improvement could do that. And the way Matthew Barnett frames it is, it's sometimes argued that since growth is exponential, a slight advantage right now might compound to become a large advantage over a long enough period of time. And that's of course a too general argument, because usually this doesn't happen. I could speculate that it's because of things like regression to the mean, but my true objections to this is more with this over a long enough period of time, because that's the crux of the issue, whether we will have a fast takeoff or not. And in general, this talk about exponentials is almost always wrong in the context of fast takeoff. What we're talking about here are hyperbolic functions, not exponential functions. And in this case, this is not a kind of argument that would be used for people talking about fast takeoff. I guess this might be an A-side, but I think actually that people who are worried about fast takeoff usually say they're worried about fast takeoff, and people who talk about continuous or discontinuous are not particularly worried. So there might be a dichotomy there between people who are worried, who talk about wall clock time, and people who are not worried, who talk about whether it's continuous or discontinuous. So it's actually possible that that's the way people talk past each other. I think I only just realized that now, and that might also not be true. Okay, the last one, continuous takeoff is relevant to alignment, and in this case, if we get, as Matthew says, if we have rapid capability gain, then something like the treacherous turn is a great worry. That's something that definitely could happen. I'm a bit here sad that he uses the word rapid, so that's I think he means if we had discontinuous capability gain, because that's kind of what he's arguing. But he argues that if we have a continuous takeoff, then the individual systems, they won't be able to obtain decisive strategic advantage because they are not sufficiently powerful compared to the predators. I think that's ignoring the possibility that the AIs could collaborate. Another thing that will be possible through if we have a continuous scenario is we can use the previous AIs to monitor the newer ones. And Matthew Barnett is very optimistic. He believes this probably means that continuous takeoff is incompatible with treacherous turns. I can see several ways where this would not be true. For instance, there is the difference between potential capability and realized capability. It's certainly possible that there is one AI who believes it has a 5% chance of taking over the world, and so it doesn't try, and then the next one believes it has like 50%, and then suddenly there's one who believes that the probability that it can take over the world is high enough that it actually tries, even though the difference between them are very low. There's also the fact that whether it's actually possible to monitor AIs, whether it's possible to monitor agents that are smarter than yourself, is potentially really hard. It's certainly unsolved. And there would be many reasons not to do that. For instance, if the projects are made by different stakeholders, that would be a strong reason not to. And finally, that's as before, the possibility that they could collaborate. So in the end, I'm somewhat less optimistic than Matthew Barnett, but I do appreciate the attempt at clarification. That is all for today. Thank you and see you next.